cul-de-sac. You ever drive into a cul-de-sac?
Mm-hmm.
You go into that street and you're like, damn, right? You got to turn around and go back out the same way you came in. Now guys, the kidney's the same way. We're going into a cul-de-sac and then we're going to turn around and come out. Okay? Now, let's follow the blood vessels going in. So guys, first blood vessel coming in is our renal artery. Okay? Renal artery. Renal artery, guys, will then bifurcate into the segmental arteries. Okay? Now, segmental arteries, guys, are going to now separate and go through the lobes. So they will now become the interlobar artery. Okay? Everybody go with that? Yes?
Yep.
Okay. Now, guys, we're in between the lobe. Now, if you look at the artery, guys, it makes a bend or an arc. So this is called the arcuate arteries. Makes an arc. Okay? Now, off of the arcuate arteries, guys, we go into the cortex. So these little things here, these are called the cortico-radiate arteries. Okay? The cortico-radiate arteries, because it's radiating out into the cortex. Okay? Now guys, we just got the blood all the way out into that cortex. Okay? Now, we're going to have to work our way back out. Okay? So we're at the end of the cul-de-sac. We're going to work our way back out. So guys, out here, we now have the cortico-radiate veins. Okay? Cortico-radiate veins. They will drain into the arcuate vein. Okay? They will go into the interlobar vein. Okay? Guys, no segmental, believe it or not. Yeah, they don't call them segmental veins. So the interlobar, and they go right into the renal vein. Okay? I don't know why they did that, but they don't call them intersegmental veins. Okay? All right, everybody cool with that? Yes? Okay, cool. All right. Okay. All right. Now, should we do the blood first? Now we'll go on to the nephron. Okay? All right. All right. Now, guys, this here is the functional unit of the kidney. This whole entire mess here is called a nephron. Okay? That is that whole mess. Okay, now, a couple of parts on the nephron. The first thing that you're going to see, guys, is a grape-like structure. That grape-like structure, guys, has a few names, as usual. Okay? It is known as the renal corpuscle. Renal corpuscle, guys, looks like a grape. Okay? It is also called Bowman's capsule. Okay? Bowman's capsule. It is also called the renal capsule.
I like renal capsule.
Okay? Want me to continue? More names? No, I'm only kidding. Okay? So guys, all that is this round thing. Okay? Now, inside that capsule is a knot, a big knot of capillaries. Does this come out?
Yes.
Guys, here's that knot of capillaries. Okay? This knot of capillaries is called the glomerulus. The knot of capillaries is called the glomerulus. Okay? Here's how you say it. Let me see if I got a big picture of it. Yeah, here's a better one. Yep. Okay? The glomerulus, guys, is that knot of capillaries. Now, guys, what I want you to realize, capillaries are what? They're the smallest blood vessels. Okay? And you remember the three types that we had?
Yes.
Continuous, fenestrated, sinusoidal. Okay? Guys, these are fenestrated capillaries. The glomerulus is fenestrated capillaries, which means they have what through their walls? Pores or slits. Remember, pores or slits, guys. Now, if you remember what I taught you guys about those capillaries, anything small enough to go through those pores or those slits will what? Leak right through them. So guys, you already know stuff that comes through there. What comes through there? Water, ions, nutrients, glucose. Okay? What else could go through there, guys? Amino acids. Okay? Amino acids. Can protein go through them?
No.
No. Too big. How about a RBC, a red blood cell?
No.
Nope. Too big. The blood stays in the blood vessels, guys. It goes through the kidney, never leaving the blood vessel, just dropping off the what? The watery substance and all the small particles. Now guys, you got to realize that not everything that just got filtered out is bad. Okay? We talked about a couple of things that are good. What's good that was in there? Water, ions, nutrients, amino acids, glucose. Okay? So guys, a lot of that stuff is good. All right? Now, the way this thing works, guys, let me pull up. The way this thing works, this whole tubule system, okay, it's really, really cool. All right? Guys, what I want you to think about, you're on a cruise ship. Thing hits an iceberg. Starts sinking. You're in the water now. Okay? You swim to an island. You get out. You're on the beach now. And you're starving your ass off. You're freezing. You don't know what the hell's on the island that's going to eat you. Okay? And you're there day after day. Now, all of a sudden, guys, you start seeing parts of your cruise ship floating by. Okay? Some of it's garbage, and some of it's pretty cool stuff. So you're on the edge of the beach, guys, and all of a sudden you see a box that says food on it. Do you want it?
Yes.
You go run, you grab a branch from a tree, you reach out, and you pull it back in. Okay? You see a jacket going by. Do you want it? Absolutely. You don't know if it's going to rain or not, or it gets cold, so you pull the jacket in. Okay? There's good stuff that you can use. Okay? Now, guys, you're hanging out, and here comes your mother-in-law. She's on a piece of wood. Do you want her? Fuck no. Let her go. Okay? And she goes back into the ocean. Okay? Guys, the kidney is the same way. This nephron is the same way. Now, guys, under normal conditions, what did I teach you about energy in the human body? It never, ever wants to what? Give up energy. So guys, if there's glucose getting dripped out here, glucose is a what? Energy source. Do we want it to go? Guys, once it hits this tube here, guys, that's called the collecting duct. Okay? Once something's in there, goodbye, Charlie. Guess where it goes? Right into your bladder, and you're going to piss it out. Okay? So, guys, between here and here, we have the chance of sucking things up again. Okay? So when glucose comes down, guys, your body says, yo, dude, that's an energy source. I need it. It reabsorbs it. Okay? Now, guys, if you find glucose in your urine, what does that tell you?
Something's wrong.
There's a problem, because normally you wouldn't find what? You wouldn't find glucose in the urine. That is not normal, guys, so something's wrong. Okay? That's what you mean. That's what you need to know. The guy's going to probably be what?
Diabetic.
Diabetic. Okay? Now, guys, proteins, these large molecules, can they go through those fenestrated capillaries? No. So they'll continue right through with the red blood cells. If you find protein, guys, over here, what does that tell you? Big problem. Not only do you have a problem that there's protein here, that means tissue destruction, but it had to smash through your screen. It had to break through the glomerulus. So now you have what? You have damage to the nephron. Okay? You are now having trouble with what system? The renal system. Guys, I've seen a lot of pro bodybuilders, because what happens, guys, I want you to think about this glomerulus as a screen. Okay? Now, guys, if our windows have screens, and I take water, I can throw it right at the screen. It's going to do what? Go right through it. Okay? If I take salt and sprinkle salt on it, it's going to go what? Right through it. Okay? Now, if I take a protein molecule and throw it at the screen, what is it going to do? Break it. No, not that won't break it, but it what? It's too big, right? Now, guys, we have force draining through. Just think of your kitchen sink, that drain. Okay, you have force of water going through there. Okay, you ever get an onion peel in there? Right? It floats around and it finds its way where? To the drain, and then it does what? It blocks it. That's what protein does, because it's too big of a molecule. Now, guys, if I start blocking that drainage, what happens to the pressure in the sink? The water goes what? Backs up. So pressure is doing what? Increasing on that onion. Okay? So the onion has two things. It can either blow through it, or it's going to stay there and start collecting what? Other things that are in your water. Okay? So guys, protein comes in, gets stuck on a screen. Another protein comes down, gets stuck on a screen. Another protein comes down, gets stuck on a screen. After a while, guys, it works like a freaking blood clot. And now you got all of this blockage and a hell of a lot of pressure behind it, and it can do what now? Smash right through there. There goes your nephron. There goes your glomerulus falling apart. Yes?
So if it's blocked, right, you're screwed either way, because then the pressure will damage it if that doesn't.
Exactly. Now this is very common, guys, in pro bodybuilders, because number one, they consume tons of protein. Number two, they're on steroids and growth hormone and other shit that they're taking. And what happens is the glomeruluses start to get damaged. And now the guy goes into kidney failure, and they wind up needing what? Kidneys. Okay? Now guys, when the kidneys go out, it also knocks out what in the human body? acid base balance, and what else?
Blood cells, red blood cells.
Red blood cells, right? What else? Nope, it backs up into the lungs, guys. Your blood pressure is going to skyrocket, okay? That's what kills the bodybuilders, guys, yes.
So, I'm sorry.
Yeah.
So when the red blood cells come, so from when we enter that glomerular capsule,
Yes.
where that's entered from the urethra, right?
What do you mean?
I mean, no, this is.
No, look. We got our abdominal aorta.
Right.
Okay, we're feeding blood in, blang, 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 all through those little things. Okay. Now we're into the capillaries. Okay, the smallest
Right.
blood vessels. What's going to happen, guys? You're going to have an afferent arteriole,
Okay.
which is going to feed blood into the glomerulus. Okay. All it does, guys, it goes in and right back out.
Oh,
Okay? So we got an intake and an exit.
So as long as it's
The
small
blood
enough-
never ever comes out of the
Right.
blood vessel. The only thing that you'll find, guys, inside Bowman's capsule is what was filtered through. Okay?
Those will go through the
Right. Could you make a circle like this? Guys, his hand's Bowman capsule, renal corpuscle. This is the glomerulus. Okay? Now, they never touch one another. There's space all around the two of them. Okay? What happens is I feed blood in here, and the blood's going to go through the fenestrated capillaries, and anything small enough is going to drip down into that renal capsule. Okay? The blood goes, it's too big, guys, so blood stays in here, goes all the way through, and just pops out the other side, continues to go. Anything big enough just goes right through the blood.
Why
Yeah.
do you have a lot of protein that's going there anyway? Shouldn't
Because it's filtering what?
blood.
What's in the blood, guys? Everything, right? This protein shuttle into muscles, gets shuttled through with the blood. Hormones get shuttled through with the blood. Nutrition gets shuttled through with the blood. Water gets shuttled through with the blood. You know, everything is in blood. That's why, guys.
Along the process, then you have a problem.
Right. If you alter this, you start getting screwed. Question?
Why do they test school-age athletes for protein?
Why do they test athletes for protein?
School-age athletes, like high school.
Because if you take a athletic advanced drug, you're going to go into positive nitrogen balance, and they'll be able to pick it up in the body. Because the body can't get rid of the protein, okay? But what it can get rid of is what? What is protein made out of? It's amino acids. So they'll get an increase in amino acids. That means that this young kid, normally you won't see amino acids coming out because kids are growing. So you'll see the young kid with increased amino acid excretion, which isn't normal.
If you work out too much and you
Yeah.
break down too much protein, I think one of the byproducts, myoglobin.
Well, myoglobin is hemoglobin for the muscle,
Right. That,
okay?
they said when you break, like if you exercise a lot, you obviously break down
Muscle tissue,
muscles.
yeah.
And they said that somehow that would damage those.
I guess it would, because your hemoglobin usually doesn't get secreted either. Okay, hemoglobin is going to do what? It's going to be passed right back. Okay, substances that we need, guys, we won't secrete it. So the hemoglobin goes right through it because the body's going to reuse it instead of what? Instead of making it new. Just regular hemoglobin, remember? On the blood, goes to the liver.
If I don't understand something, then I go to the TV and I watch YouTube
Like
videos
athletes
online.
that overdo it,
Yeah, what about it?
like,
But I mostly
you said that
focus
you
on
when you break down so much muscle, like one that you use that I used to rap all my life.
Yeah, well, what's going to happen there is you're just constantly breaking it down, and eventually, when the muscles break down, they also secrete something called creatine.
Oh,
Right, so you'll see that popping up into the urine, which normally shouldn't be in high amounts there. That indicates blood, muscle
What
breakdown.
part of that is toxic or bad to that kidney? That part that would cause it.
It's not that the part of it's doing it, it's that it's passing something that it normally wouldn't pass. That's what damages the kidney. Okay? Not that it's toxic to the kidney. This shit shouldn't go through here. Okay? It's too big of a molecule. And you gotta remember, guys, just think of your screen on your bedroom. Okay? Those grits are so small that bugs can't get through. But if your brother took a pen and popped one of them, he just did what? He made a bigger hole. So any bug that finds that hole can come through. That's what happens to these molecules. If you get a molecule that normally wouldn't go through the kidney, and you have so much of it, okay, and there's now a backup of it, it's going to eventually just clog that screen for months or years until, ow. Now once it rips through there, now your nephron's letting stuff through there that normally wouldn't go through.
I never leave those tests thinking I do that. Yeah, me too. I was so strong.
Viruses are so small they'll go right through that. Yep. Yep.
So there's no repairing that mesh.
What's that?
That mesh never gets repaired. The nephron. It's like
No, it doesn't repair too well. Kidneys don't repair. The reason why they don't repair well is because they're constantly working. There's no downtime. It ain't like a muscle where, if you do too much damage, you can rest the muscle. Your kidneys are constantly working. Constantly. The only way to stop them is to do what? Give them a break if you do, throw them on what? Dialysis. Okay? You give the guy a break. That's why they use dialysis, to help the guy from going into kidney failure. Okay? Let the machine take up some of the function, off of the kidney.
The severity of the damage will determine whether it's
I
kidney
would think
failure.
so. What's that?
The severity of the damage would determine whether it's considered.
Totally, absolutely. How much damage you have is all dependent upon, what shape these suckers are in.
It's also damage that's in kidney stones.
Yeah, kidney stones, guys. This
So
semester.
we didn't discover a synthetic way to make that capsule yet?
Nope. Guys, I passed a kidney stone a couple of weeks ago, not in class, but during me teaching you guys. I went home, guys, and I've had patients that had kidney stones. I had no pain. Not 1 ounce of pain. Okay? No indication, no nothing. I went to my bathroom, and I started leaking, and guess what it was? Blood. I was like, I'm dead. No pain. This ain't a good one. Okay? So I wound up stopping my stream, and I grabbed one of the white plastic cups, and I started peeing into that. And for like a day and a half, guys, it was blood, blood and water, blood, blood and water. And then finally, I heard something go chink on the bottom, and I emptied it out. I flushed it with the water, and then I looked down, and it was a little kidney stone. But guys, it was like a meteor. It was all very sharp edges, like a razor blade, and it must have went through my ureter and just sliced it. I had no pain. It was so sharp, guys. I had no pain at all. I have patients that had them, but their stones were really smooth. Those smooth stones, those are the ones, guys, that get huge. Those things, sometimes you have to go in and surgically remove them. They're so big. They'll be 3-4 inches round. Okay? Mine were these little tiny, super sharp, really sharp. Okay? So I passed that, and like I said, I had not one classical symptom of a stone. And I think it was from, I don't know if you guys saw me, I was bringing protein drinks to school because I don't have time to eat. I go right from here to the other college and teach till 10. So I've been drinking these protein, pure protein drinks. When I'm at Costco, and I drink 3 of them a day, and I haven't been training since we started summer school. So we're consuming all of this protein, and apparently the calcium in there combined together and whacked me out. No, I won't do it until I start training
I need
again.
like at least
Yeah, big time.
because right now where I'm gauging, if I get
Inside your kidney. Right about
like an 89.7. So then I'm yeah.
right about in here by the calyx. then they'll get thrown into your system, and now you're passing it. Right? So people freak out with that because a lot of times they get stuck there.
At least for
You
this,
know?
like. I
And
can
if you
mark
get a
it.
big one, I'm telling you, it's the only time I've seen grown men cry. When they came into my office, they were literally had tears, and I knew right away it wasn't their back that was
I'm
giving them the
gonna try
back
it
pain.
too, like.
You know, I did a
when we're
couple
setting
of
up
these
my
moves on
weight.
them. I'm
I
like,
usually write on
dude, you're going to the hospital, you got kidney stones.
I download the slides for
Very, very bad.
And then you just
Okay.
type it out.
So,
I think Brian's gonna put money in. I don't have time for that.
So
And
where
put them
the
in red.
license, is
Everything
that
says put it
beyond that part?
And then
Beyond what
you
part?
go do the
Beyond
you don't have to do the whole thing.
glomerulus, or is it
The
lower
person
down?
don't
It says
understand.
over-
no, it's going to be lower down. It's going to be after the glomerulus. It's going to wind up getting stuck in these renal papillae, and then come on out.
Oh, so it's not necessarily causing
forget the writing shit.
to
Like, if you're gonna
structure.
draw,
It's
like,
in
the drawing,
glomerulus then. But over here, it doesn't
writing
seem to be
everything
that.
down.
That
No,
could-
no, no, it's not that bad. It's just, you know, the only time they're bad is
Because part
if
of
you,
the problem
if
is
you,
like I'll write things down.
get them
but
blocked.
Then I won't like
If you
read
block
them,
something,
'cause
then you're
it's such a
screwed, because then the
mess,
pressure
you know?
behind it keeps
You
building.
type it.
Right,
And then
right, and
I know you
especially
wanna
if
listen
you
to them
block,
over
you know
and
the
over.
worst part to block?
So then when you're typing, just make sure
Have
you
them
take
go into the bladder.
and then delete the slides that I'm gonna send you an email. Delete the slides that he doesn't even use.
Right.
But if he's hesitating, keep that shit in there.
If they get into the bladder here, if they come through here, and then they form inside the bladder and they block that, it's like, that's as close to childbirth as a guy's ever gonna get. Cheers. Okay? As close to childbirth as he's gonna get, passing those stones. Okay?
The only problem, no oxytocin being given off.
What's that? No, it's calcification. The protein I was taking had calcium in it. So that apparently coagulated and went through my ureters with no problem. I think it just cut them and made it bleed like crazy. So 2 days later, I was fine. I'm alive again, teaching class. I was like, holy shit, I'm gonna die of cancer. You know, I won't be able to come back and teach my summer class.
Right.
I was like, you
That's
know,
what you're
ready to make arrangements. It's scary, guys, when all of a sudden there's blood there. Okay. Okay, whoop, let's back up.
You know that also with the high blood pressure.
And also just try to read a little bit of the
After you do that,
just read over everything he does.
I'm gonna die. My
It's just
first
a 2
words
hours,
I'm throwing on.
1 hour.
I know.
And then at the end, you don't have to study the
Okay, now guys, we're going to take a look at this entire nephron, okay? Now, once again, over here, guys, the round surface that you see, that is called Bowman's capsule. Now, Bowman's capsule, guys, is the capsule that is around the what? The glomerulus, those capillaries, okay? Now, there's a difference between Bowman's capsule and the renal corpuscle, okay? Even though they look the same. Guys, make your capsule. Here's the capsule. What's it called? Bowman's capsule / renal capsule, okay? Guys, if I add the glomerulus to Bowman's capsule, guess what it's called? A renal corpuscle. So a renal corpuscle is the capsule and the glomerulus. Okay?
So just the capsule alone is Bowman's capsule.
Yes, capsule alone is Bowman's capsule or renal capsule. A renal corpuscle is the capsule and the glomerulus. Okay, everybody's good with that? Okay. Now guys, let's take a nice trip through this little organ here, the nephron. So guys, what's going to happen, remember, blood's coming in one side of the capillary knot called the glomerulus. It hits those fenestrated capillaries, and we are losing fluid and some elements inside of it, okay? Now that stuff that's draining out, guys, is called a filtrate. So the filtrate, guys, is the fluid that you're going to see inside of the Bowman's capsule, okay? Now, that fluid, guys, now enters the first part here of the tubule system, and you'll see that it has a lot of turns to it. That is called convoluted. Convoluted, guys, means it's bent upon itself, okay? So right here, guys, closest to the glomerulus, these are called the proximal convoluted tubule, okay? Proximal convoluted tubule. You can also write for me, guys, PCT, proximal convoluted tubule, okay? Everybody good? Okay. Now, from the convoluted tubule, guys, we are now heading downward, okay? And there's differences in the tube. Some will be thick or wide, and some will be thin, okay? So we call them by what they look like. This would be the descending thick tube or limb. This here would be the descending thin tube or limb. Okay, everybody go with that?
Mm-hmm.
Now, at the bottom, guys, we make a U-turn. That U-turn is called the nephron loop. Okay? Also called, yes, the loop of Henle. Okay? Nephron loop, also called the loop of Henle. Now, our fluid, guys, is now traveling upward. So we are in the ascending limb. And then you just look at it, is it thin or thick? Okay? So here we have the ascending thin limb. We go to the ascending thick limb. Okay? And now, guys, we go into another group of tubes that are all curved. So these now are called the distal convoluted tubules. And once again for you, DCT. Okay? Distal convoluted tubules, guys. And then from there we go into our collecting duct. Okay? Now the collecting duct, guys, these will be running up and down